Hello, welcome back to my shop. Well, I finally broke down and bought a 3D printer last week. I justified the purchase by telling myself that I could use it to build hard or impossible to find parts for old radios and other things that I fix. When I got it home, I read the whole manual and realized that this 3D printing thing is not nearly as hard as they make it out to be on YouTube videos. The actual printing is not as complicated as you think. And it used to be that the program that you used to prepare the designs was only for CAD operators and geeks. Well, it's not anymore. The first thing I printed was this little knurled knob. That's one of the designs that came on the card with the computer, and it worked pretty good. But as you can see, it's a little bit warped, and that's because I didn't wait for it to cool down enough. So that's the first lesson learned. Wait for the thing to cool down before you try to pry it off of the plate on the printer with the little knife that they give you. And the next thing I printed was this little vase. It also came on the card that came with the machine, and I was absolutely amazed at just how well the thing did. It was nice, and it's very thin walls on this thing, and it's pretty good size height wise, and it worked beautifully. I can't see any blemishes or anything on it, and I was really happy with that. So now I decided it was time to make something from scratch. I searched around on the web and found what to me looked like about the easiest design CAD program out there, and it's called Tinkercad. It's an online service that you can just get online and build whatever you want in their little CAD program and save it out to a file on your computer. They've got all kinds of basic shapes, and all of those shapes can be either solids or holes. By manipulating these holes inside or around other solid pieces is how you make everything with the bends and the flats and all that stuff on it that you need. After pondering on it for a good while, like actually overnight, I decided on making a little parts box that could hold a bunch of nuts and screws and parts and things that I take out of machines when I fix them, and enough boxes in it to separate the parts so that they won't get confused when I have to put it back together. This little project taught me a lot of little things. The first was how to actually get around in Tinkercad. In order to make things, you have to use a combination of solids and holes, like I said before, and any basic shape can be either. In order to make this box, I first made a solid cube that was about 20 by 20 by 20 millimeters. I next made a rectangular box about 140 millimeters long by 90 millimeters wide and 20 millimeters deep. I placed that first cube in the upper left-hand corner of the box and turned it into a hole. Well, this resulted in having a nice square hole all the way through the bigger box, which wasn't going to work. So I reduced the size of the box by a couple of millimeters on depth, down to 18 millimeters, and drug it off of the floor of the working bed by 2 millimeters. That gave me what I wanted. It was a nice square hole with a bottom. So I copied and pasted that cube 5 times and placed them exactly 1 millimeter apart. Then I copied and pasted the whole set of 6 up on the top and placed them 1 millimeters below the first set, and that gave me 2 rows of these little boxes. Then I made a box that was about, let's see, I think it's 44 millimeters by 20 millimeters and 18 millimeters deep. Put that inside of the big box, copied it 2 more times, put them a millimeter apart, and then made one big long box along the bottom, as you can see. After a bit of fiddling around and moving things around, I got it so it all fit inside the box, and it's no longer exactly the same dimensions as I wanted, but you know, who cares? It's a one-off, and I don't care. And so then all I had to do was save that into a file called an STL file that you then take over and download onto your computer and run it through the program. The program I used came with the machine, and that program, then you save it out and it saves the file as G-code. What G-code does is it makes slices of your drawing that the printer reads and prints one at a time, very slowly. This 3D printing stuff's not fast by any means, but I gotta tell you, it is fun. And it's kind of mesmerizing to watch, too. I did learn a little bit about the printer setup, though, on this one. For one thing, the temperature of the little nozzle that the filament is forced through is critical. Not so much for the actual melting of the filament, but for how well the first layer sticks to the printer bed. If the temperature is too low, it will not stick, and your first layer will get all messed up, and it won't work. So I wondered what was going on, so I went back and looked at the recommendations of the program that came with it. And the recommendation for PLA, which is the type of filament that I'm using, there are many types of filaments that you can use, including one that's got wood in it, so you can make something that looks like wood. Not recommended because the wood gets all plugged up inside of the little hole, because that little hole is like half a millimeter wide. It's very small. And the recommendation said 210 degrees is used for PLA. Well, the default setting on my printer was was 185, and that just it didn't work for this big box because it just messed up the bottom too bad. When I changed it to 210, it worked just fine, and I kept the plate, the bed of the printer at 50 degrees Celsius, which is, it says just make it whatever works. Well, it works well at 50, so I left it there. By the way, if you do get one of these, you want to get one with a heated bed. You're going to need that. Trust me on this. It says PLA will stick without a heated bed. I'm not so sure about that after playing with this thing. So I got done. I had my little parts box, and it works just fine. It's exactly what I wanted. Now I had to set about proving my justification for buying this thing, and that it was actually something I could justify. I got back on Tinkercad and I designed a proof of concept knob to replace a broken one on a piece of test equipment I have. And here's the first try. It is simple and it's not quite right, but it did teach me a bunch of other things about Tinkercad, like how to work with cylinders. After a bit of trial and error and playing around, it was fun. It involves using the cylinders inside of cylinders and making them holes, getting the holes exactly centered. You can control all of this very well with the grid that's on the program on Tinkercad. You can take that down to like 0.25 millimeters and use your arrow keys to move it all around. It's really quite simple, and it just takes time to learn it. But once you do, it's pretty simple to make something. Then I said, okay, this looks okay, but it's not right. So I went back on and I took the old knob as a guide and got out my calipers and started measuring the thing off. And after quite a bit of playing around, I came up with this design. This involves a lot of little cylinders that are actually holes to make the knurled surface around the outside of the knob. It also has a couple of small boxes that are holes too that flatten the ends of the paddles on either side of it. The first print has a small hole in the bottom, just the size of the shaft on the equipment I wanted to use it on. And I was going to try to tap the set screw holes into the plastic, but later decided I couldn't do that because the plastic's just not hard enough or strong enough to hold the little set screws that go inside. So what I eventually ended up doing was just destroying the old knob, pulling out a piece of metal that was an insert in the bottom of the knob that actually had the set screw screws in it that, so that they would fit and they tighten down and be locked in solid. I had to destroy the knob on that one, so I was committed. I had to finish this. And I went back to the design and made a bigger hole. And I made the bigger hole just almost exactly the same size as the outside diameter of that collet that I needed to put down inside of there. And printed the whole thing out in black, figuring this is going to be my last shot because the rest of the knobs on there are black. So I did. And black is a little different than white. It's interestingly enough, probably formulation of some sort, but it didn't come out as smooth as the white does, as you might be able to tell. But it looks okay for my job here, what I have, what I need it for. And I was lucky that I was able to, instead of being able to force that collet into the bottom, which I thought would just break it because it was really a tight fit, I was able to use my soldering iron and heat it up enough to just melt that collet down inside of there until it bottomed out where it was supposed to bottom out. And it stuck. It's in there perfect. The one thing I did do is I drilled holes through the side of the knob very slowly, and actually managed to match up the holes in the side of the knob with the screw hole in that collet twice, and that was just plain flat out luck. If I ever do this again, I'm going to build the holes for the set screws right into the design. It'll do that. It'll make a nice hole in the side of something for you. Anyway, but here's the final product and how it came out. It's on my distortion analyzer. This is a Hewlett-Packard 332A distortion analyzer. And now all the knobs are whole, and they all work, and they tighten down, and everything's great. So, now I know I can make knobs, and I'm sure I can make lots of other things too. So justification justified. Besides, this 3D printing stuff is a lot of fun. Really, it is. You just let your imagination go wild. Thanks for watching, and be sure to give this video a thumbs up, and don't forget to subscribe if you want to see more of my playing around in the shop.